But contrary to these predictions, biologists are learning that homologous structures can be produced by different genes and follow different patterns of development. For example, biologists consider the body segments of fruit flies and wasps as homologous. Darwinism predicts that these similarities should be due to the same gene. But in fact, different genes account for the development of body segments in these insects. This contradicts the idea that homology must point to common ancestry. In the same way, many body structures considered homologous by biologists develop in embryos in fundamentally different ways. One example is the gut in vertebrates.
If the Darwinian theory were correct, the process by which the gut is constructed should itself be homologous. In fact, this isn't the case. We know, for instance, that in different vertebrates, the gut is constructed in very different ways during development.
In sharks, the gut develops from cells in the roof of the embryonic cavity. In lampreys, the gut develops from cells on the floor of the embryonic cavity. And in frogs, the gut develops from cells in both the roof and the floor.
So you have a homologous structure in vertebrates that is built in one way in a shark, in one way in a lamprey, in another way in frogs, and you've got these very different developmental pathways converging to the same structure. This is very hard to reconcile with Darwinian common descent.
These marine reptiles were built on much the same plan as you are.
I would say in the past 20 years of studying this problem that biology is now entering what can only be described as a revolution. Because the evidence is so overwhelmingly against the conventional neo-Darwinian view.
Now, what about those other reptiles that flew in the air?
If homology doesn't provide evidence for the tree of life, what does? A second proof usually offered is the fossil record. According to most biology textbooks, fossils show the gradual development of life from simple to complex over hundreds of millions of years. But a growing number of scientists say that this textbook story is incomplete and even misleading. Because it ignores an extraordinary event in the history of life known as the Cambrian explosion.
The Cambrian explosion is a term that refers to the geologically sudden appearance of all the major, or most of the major groups of animals at about the same time, geologically speaking.
Most geologists date the Cambrian explosion at 530 to 520 million years ago.
The Cambrian explosion is a name given to a geologic event, really, the appearance in the fossil record over a period of about 10 million years or slightly less. Of skeletonized fauna that includes many living phyla for the first time.
Animals with similar body plans are grouped together to form various phyla.
Indeed, if you look at the tree of life, you can infer that nearly or all living phyla had evolved by the end of the explosion period.
The Cambrian explosion has been called life's Big Bang, or at least animals' Big Bang, because in the Cambrian explosion, most of the major forms of animals appear very suddenly in a geological sense. From nothing, we have almost everything. Almost overnight, geologically speaking. This remains mysterious. Nobody really understands how this happened.
The explosion is real in the sense that the fossils are real. There they are. Explaining it, however, is controversial. We're not sure just how far back animals originated before the explosion or what the events were that led up to it.
In Darwin's theory, if you think of the branching tree, Darwin's branching tree, the common ancestor down here and the different modern forms of animals up here, you would have one form to begin with, and then it would gradually diverge into slightly different forms and more different until you get the major differences that we see now. The problem with the Cambrian explosion is that all these major differences appear together at the same time, with no fossil evidence that they descended from this common ancestor.
You have a sudden emergence of new biological form and structure. And the suddenness of it defies the Darwinian mechanism's ability to produce new structure. Darwin believed that his mechanism must act slowly through small, gradual, incremental changes.